So I ask you to join me in welcoming Chris Valasek of Uber to our event.
Awesome. All right, so how's everyone doing this morning? Good? Get coffee, breakfast? It's the most important meal of the day. So, as he said, I now work at Uber ATC, so if you have any questions about that, Uber ATC does mapping, safety, and autonomy. And that's all I'm going to say about it, so no questions about that. I was a programmer in a former life. I used to actually write software for ISS's intrusion prevention and detection system. So at one point, I was a programmer. I was just not all that good at it. And instead, I went into research, and I guess we have the product that is me today. Most people obviously know me for the work I did with the Windows heap reverse engineering, right? Everyone read those papers? No? Yeah, obviously not. Obviously, Charlie and I have been doing the car hacking stuff for a couple years. It's been fun. I'm going to talk a lot about cars, but I'm going to try to relate it to stuff that is on the internet, right? Fun fact, I once jumped rope for 45 minutes without missing. It's probably one of the highest accomplishments in my entire life. Most proud of that. The first thing I'll talk about is what I'm calling IoT security versus IO take it easy security. While there's different impacts for different things, I think we can learn lessons from both. Then we'll move into the complexities. This stuff is more than just software, right? It's where software meets hardware, and it makes security and security solutions a bit more complex. Then I invented a thing the other day called the IoT responsibility triangle. It's pretty sweet. We're going to talk about it. And then finally, here's what I want to see as we move on, and then you can ask me any questions. Does that look good? Oh, I always love posing for the picture. We'll cover first IO take it easy. A really fun example is some research that Michael Coppola did a couple years ago where he hacked a Furby. And it was amazing because he documented the teardown of the actual Furby, the communications, reverse engineered firmware. The kid was even doing acid baths in his dorm room to, delayer these chips. Amazing research. And you could learn a lot from it because it taught you about these microcontrollers and how to get the firmware and how to reverse engineer them and how communications worked for things that are system on a chip, right? I thought it was fantastic, and it was really great. But to be honest, right, it doesn't really affect safety or privacy. Yeah, I guess you could hack one, and you could spy using a Furby, but if you're going to do that, just plant a bug in someone's house. It doesn't have high impact, but there's a lot of lessons to be learned from it because not everyone knows how to do these teardowns. Not everyone can reverse engineer as good as Michael. So these lessons are put out there so other people can learn how to do these things. And I still think it's very worthwhile to have this type of research be done and not instantly dismiss it as, a child's play toy, literally, right? Obviously, I have to talk about myself here. Then you have, I think, the other end of the spectrum, which is this high impact stuff. Some guy named Charlie Miller and Chris Valasek ended up doing this car research, right? And we remotely compromised a vehicle from A to Z over the cell network, basically over the internet. Huge impact because you had this massive recall, which I thought was kind of amazing, right? A recall of physical things for a software security vulnerability, and there was a lot of news, and it was high impact, right? Because there's safety. People concerned that if you wreck a car, you could die, get hurt. Again, very important. Just I think higher impact because it directly affects safety. But I don't think the lower impact things should be dismissed. Additionally, I don't think that every IoT vulnerability is high impact. I think everyone wants to flip out when it's something that isn't just a PC that's on the internet that there's a vulnerability. Software has vulnerabilities. I think we've learned that. There will always be vulnerabilities. You have to judge how impactful these things are based on what the product does, what the vulnerability is, and how it'll be used in the future. You know, I always said what might be in a Furby today could be in something as complex as a car tomorrow, right? These systems on a chip, these microprocessors, the communication channels, they're everywhere. They're not just limited to one thing or another. You know, purchasers buy these things in bulk. So you can have something that does comms in a Furby that may be used in a SCADA system. I mean, you never know. So I don't think you should instantly dismiss research on small little things that don't have high impact right away, because it could have similarities to something that would have high impact. And I want more information out there. I think everyone here can agree that there's a shortage of quality information security people, right? The way I see it, the way to ramp that up is get more information out there. You know, I don't think there's a lot of people hacking cars because it's expensive and there's not a lot of information. I hope there's more people looking at this stuff now that we put out information. I hope there's more people that looking at the same microprocessors that Michael did in the Furby, because he put that out there. You know, high impact research can stem from low impact research. You can be doing this stuff that's simple and considered, you know, toyish, but you learn on these systems. They're easy to acquire. And once you have the expertise, you probably are more confident to say, like, hey, I'll write a proposal and try to get you know, a drone or a car or something crazy. But you're not going to do that if you don't have the confidence that you can actually accomplish your task, which is to do a security assessment of something. So I don't like that things like that get dismissed. That's one of the hard parts with InfoSec. It's one of the things I hate most about the industry is everyone's a jerk. Like, everyone wants to tell you what you can and can't do. You know, we're computer hackers, man. We shouldn't care what other people think. You should do it because you like it and it's interesting to you. If you want to hack skateboards or you want to hack Furbies, go for it, man. Publish it and talk about it at a conference. I'm not the one to tell you what you can and can't do. Additionally, we like to make fun of people. Again, it's bad. Like, ha ha ha, you know, GM has this OnStar, they're stupid, they don't know anything about internet. We didn't all come out of the womb knowing everything about internet security. These companies that make these things, you know, some of them are powerhouses in electrical and mechanical engineering. That's a feat in its own. I could never create these things, but I just find that I'm good at breaking them. So I don't think you should instantly, you know, really get on someone and chastise them for not having perfect security first off, because they're not going to know, and they need our help. You know, the way I see it, we're InfoSec people are shepherds of the internet, and we're going to tell you where you mess up, and hopefully we're going to help you move forward and make it better. So I don't know. Our industry's full of snarks. I wish it would die down a little bit, but I don't see it because everyone gets 140 characters to voice their opinion, right? Other complexities. Specifically with cars and SCADA, this stuff was developed a long time ago. Everyone wonders why there's, you know, implicit levels of trust and no authorization, authentication, encryption. This stuff was invented in the late 70s and early 80s, man. These people didn't have to worry about this stuff. They didn't have a crystal ball that would show what the world is going to look like in 2015. So they developed these things the best they could at the time. CAN bus, for example, kind of invented by Bosch, I think late 70s, early 80s, right? And it was a system for a bunch of nodes to communicate in a very reliable and quick fashion. And at the time, if you had one of these, you were the one putting all the sensors and nodes on these things. And you're like, well, I made it. It's controlled. I should be able to trust everything because I developed the hardware and software that communicates on this. And that was before we connected things. And everyone says, well, you should just bolt internet onto everything. That's probably true, but at the same time, there's a lot of complexities that these companies have that regular software people don't have. For example, I told you I'm the heap guy. You know, Microsoft made this isolated heap. Basically, it said, hey, any object that was of this type can't be some other type. And it helps with use after free vulnerabilities and makes browsers more secure. It's awesome. They completely refactored this, right, just recently. They can do that because it's just software. They don't care what hardware this heap is running on. They don't care if it's a laptop, a desktop, you know, even if it's Apple's hardware. It just runs, and they're abstracted from that. Unfortunately, makers of things, cars, for example, can't do that. So the diagram there is the diagram from the Jeep Cherokee, right? And you see the big problem was the radio that dealt with all the outside world stuff talked to both CAN buses that had important stuff, braking, steering, acceleration, blah, 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 right? They can't just say, well, you know what? Bring every car in, and we'll completely re-architect the network architecture, and we'll make sure there's filters between those two things. That's impossible for them to do, because you need to test those things, and you need to ensure they work. And I don't think they have enough time or money to add all this new hardware on the current version. That's why they have these long release cycles, and they have to add these things over time. So you have to remember that you want to point out that there's, some lack of filtering or protection, but they can't just refactor it and release a new software release. They can do some things with software, but a lot of the times they have to replace hardware. And honestly, that's an impossibility for a large company that has a lot of things. So there's a lot of complexities with stuff. And that's why I think that responsibility for the security of these things should be shared amongst many people, not just one individual party. Look at that diagram. That took me all of 30 seconds to make in PowerPoint. I should definitely work for a graphic design company. So my triangle of responsibility involves three parties. Your tier ones, these are people that supply parts to companies, right? I'll go through an example in the car, but basically you're a company and you make a product and you buy widgets from company X. Company X is your tier one because they give you the product. Then you have the OEMs, right? They're the ones that contact the tier ones, get all these pieces and put it all together and make something awesome, whether it's a Furby or automobile. So they're depending on their suppliers to give them good parts, right? But at the same time, they're putting it together and adding functionality. So they're augmenting these things that they buy. And lastly, to put the internet in the Internet of Things, is you have these telecommunication carriers, right? They make sure that these parts supplied by the tier one to the OEM can communicate with the world, right? Your Sprints of the world, your AT&Ts of the world, anyone that really does communications. So really, they all work together to make these products that we know and love. But I think they should all share responsibility about security as well. And I'm a color by numbers guy, so I want to go through the GPAC from all these three different angles. The tier one in this instance was Harman. Harman actually made the Uconnect system. And Fiat Chrysler bought a bunch of these Uconnects, probably like 1.4 million of them, from Harman to put in their Fiat Chrysler cars. But not all the weight's on Fiat Chrysler, because if you look, here's a snippet of the code. There's the code that was made 1.4 million cars vulnerable, the execute method. We basically could pass it stuff, it would execute it. If you look at the namespace, com.harman.service.navtrailservice, this was code written by Harman. This was code written by a tier one and put onto this machine and given to Fiat Chrysler. So while they had this system, they probably don't have the capability to completely audit every piece of hardware they get from every supplier, because they have a bunch of tier ones they buy from. So these tier ones need to think about security before they give these products to the people that consume them, right? You can't put all the blame on FCA when Harman gave them a piece of equipment that had this type of vulnerability. They need to be doing their own security assessments of their own devices that they give to their OEMs. Secondly, you have a carrier, right? You have Sprint in this case. The way we were able to communicate with these cars was we bought a burner phone, or I was dumb and got a 2-year Sprint plan, which I'm still paying off. And we made it the internet hotspot, and then that was our internet, right? And from there, we could touch every car. And there's probably more stuff than cars on that network, because from our perspective, it was flat, right? So any device on that carrier could talk to any other device that did stuff, and we could hit 1.4 million cars. And there's the port. It was port 6667, open, just TCP/IP, how you would normally assess a network. We did from these phones. Now, if you ask me, I don't think burner phones bought from Walmart should be on the same, VLAN as all the cars or all the vending machines or all the whatever it may be, right? So you want your carrier to be aware of what's on their network and work with the OEMs to make sure that they have a certain level of awareness and we're able to, segment their networks properly. While FCA released a patch and did the recall, which was great for them, Sprint actually blocked all the ports, all those ones that say open right there on the screen. If you rescanned after Sprint fixed it, would say filtered, right? This prevented the attack more than anything. While the recall was great and the patch was great, not being able to hit these cars over Sprint's network stopped actual attacks ever from happening, right? Because if you can't do it over the cell carrier, you have to be maybe close proximity to the vehicle to use Wi-Fi if they have that. But you were no longer able to do the attack because I don't think every car is going to be patched ever that has this vulnerability. That's just the reality of it, right? People don't pay attention. They definitely got a USB stick in the mail that, most people would say don't plug into your computer. So there's a lot of things that Sprint did as a carrier to remediate this problem. And lastly, you have the OEM that takes this tier 1 supplier's part, puts it in whatever it is they make, and then connects it to, we'll say, the internet via their carrier. These are the people that get a lot of the blame, but at the same time, they make mistakes too. So, the way we were able to actually physically control the Jeep was there was code to update the chip that communicated with the in-vehicle network from the chip that did radio stuff. There was no signing of the firmware, no authentication, things like that. So, this is their bad, and they're the one putting this machine all together with parts from tier 1s and talking to carriers, so they should know. I think they all should have some responsibility in vulnerabilities and just the general vulnerabilities of things they make. FCA took it on the chin, right? They recalled all the cars, super expensive. They released a patch, super expensive. They took the knock on shareholder confidence, super expensive. But that's not to say they're totally at blame for all of this, right? They didn't make all those parts, and they didn't write all the code. Specifically, the code that we use to hack in, they didn't write. Right? So, while they put this part in their car, they probably had a certain level of confidence that their tier 1 was providing them pieces that made their overall system secure. And unfortunately, they can't have that assumption, right? And it's expensive to test these types of things. So, it's hard to say what to do, but you definitely, as an OEM, someone who buys things, you need to question security, and you need to test implementations of. As I said before, Sprint was the most impactful in remediating this process because they shut it down from a network level, right? And apparently, there was probably some conversation with FCA with their hair on fire saying, hey, could you block this port? And they probably said, we don't know. We'll break all the cars, they don't know. They eventually turned it off. And what do you know? Nothing really broke. But I think these parties need to be in more communication, and they need to work together to ensure that the networks that they use for their products are kind of, each company is aware of each other from what they do, because I assume a carrier just wants to be a data mule, but unfortunately I think they share some of the responsibility for the security of the products they put on their network, right? And lastly, you have the tier 1. In our case, I don't think they ever released a patch. I always wanted to know if there were more Uconnect systems that weren't in FCA vehicles or on Sprint network that exist. We don't know, right? Have these flaws been fundamentally fixed? We don't know. The thing that you want to ask of these companies is when they do know about vulnerabilities that affect a certain OEM, that they get the problems fixed for all their clients, right? As a business, you would want to ensure that all those parts that you've shipped out have a security fix to them, not just the people that got popped. So I think all these people share some level of responsibility for securing the stuff on their networks, the parts that they sell people, and the people that put it all together. So what do I want to see? I know everyone always wants to say like, why does that need Bluetooth, or why does that need Wi-Fi or internet? I'm not the internet police. I'm not here to tell you what you can and cannot put on a product you're making. If consumers want Bluetooth in their baby monitor or they want Wi-Fi in their car, that's up to them. And I don't think security people should try to say what you can and can't have in your product. What we should do is try to help people put forth effort to better secure these devices and be aware of security when designing them. Secure by design is all fine, but I think as was said before, people make mistakes, right? You need design review and you need implementation review, and you need remediation review. What are you gonna do when this thing has a problem? So I want people to innovate, but secure late, trademark pending. I think this goes without saying, but OTA updates seem like a must, right? I would think the rule of thumb is if you're going to connect it, you're going to have to update it. If it runs code, you're probably going to have to fix that code, because as humans, we've proven that we're bad at writing code, and we're bad at writing secure code. Every Patch Tuesday, second Tuesday every month, there's always a patch for Internet Explorer. We've been trying to write a good Internet Explorer for what, 20 years, 20 plus years? And it's not gonna happen. These things are complex. The more input you take from the outside and the more data processing you do, the more vulnerabilities there's gonna be. That's just how life is. But you should figure out a way to update these things when flaws are found. As we saw before, it was probably pretty expensive for Chrysler to recall 1.4 million vehicles, send out those USB sticks, right? I'm not, trying to continually punch them in the face, but if you're gonna have internet-connected stuff, you would think you would want the ability to update that. And I understand there's probably products that aren't made to be updated because they're limited use and limited impact. But if you have something that, say, is controlling physical aspects of a big machine, I think you want ways to update that without asking everyone courteously to come bring it back to you to get it fixed. Lastly, at least from my perspective, researchers keep researching. I want more people to look at this stuff. That's why I like all the low impact IoT research, because it teaches people how to do these things. It's really an intimidating task the first time you have a circuit board and you're trying to pull a chip off of and you're burning your fingers with your soldering iron. You don't know what you're doing. It sucks. It really does. But it helps when you have diagrams and other people have done the same, and it gives you inspiration to keep doing these things. So I want the Michael Coppolas of the world to keep doing these things. I want people to look at cars. Like, no one has a monopoly on research. I'm always amazed. Like, I want more people to do car research. Like, Charlie and I don't have a monopoly on it. We release all this information because we want people to look at these things. I want more security people, more researchers to look at all the stuff out there, because hopefully by continually reviewing pieces of software and hardware, we can make them better and we can have more stuff. I like technology. I like all the cool stuff we're gonna have. I'm gonna be mad that I'm gonna be dead before like 500 years from now when we have really cool stuff, right? So like, let's make cool stuff now so I can have it, because I'm selfish. That's about it, and those are my thoughts on cars, internet security of things, and all that stuff. So if there's any questions, let me know.
Thank you. Morning.
How you doing?
I'm getting caffeinated, so we're getting there.
Beautiful.
So question for you. So I've seen the work and the work that's been done in the past with the Prius, I think it was a Ford Explorer. So I have to admit, personally, I see this as this particular proof of concept as a double-edged sword, and I want to hear your thoughts on this. So doing that on a freeway seemed a little dodgy, so that's one side of the sword. Now the other side of it I see is, now it's getting real attention. So I'm flummoxed on how to take the whole thing. So I'm curious, actually, if you could just, I'd love to understand.
I'm not flummoxed at all.
Okay, but why on a freeway? So I guess that's the question I have for you.
So a few things. First of all, you guys see the movies, right? Like they can like make cars flip upside down. You ever see someone do something sensational on an internet video? Videos can be edited to make things look more dangerous than they actually are. Second of all, if you watch 60 Minutes a few months before that, the UWash researchers did their exact attack from 2011 on a car in a parking lot with helmets and cones. Does anyone remember seeing that? All right, guess what happened? Nothing. So we wanted to relate to a person. And in all reality, what we did was make it so the equivalent of you taking your foot off the acceleration pedal. So I have zero regrets, and I think the impact was worthwhile what we did.
Gonne Lambrink with UL. A question I have, this CAN bus element is coming back in a lot of presentations on car security and car safety. Any ideas on better protecting this bus? Is it like about data segregation, or like what are the measures that you foresee will be feasible to implement as a design for the CAN bus?
Yeah, as I said before, I'm sure there's people way more qualified than me figuring out how to better design a CAN bus. What you have to look at is how many are out there and how many are going to be like they are for now. Right? I think the average lifespan of a car in America is 11.2 years. We have that stat somewhere. So you can't just think about how to fix it. You have to think about how to work with what you have. That's why, like, Charlie and I created this intrusion detection and prevention system for a CAN bus. So at least you could detect attacks. So I think things like that hold merit because you can't change the physical architecture and how they work, but hopefully you can add something new to it that will improve the security.
Great, thank you very much. It's fascinating stuff. So
Thank
you
you
for the great work. I was just curious, you talked a little bit about this, if maybe you can dig a little bit deeper into it, because prior to this coming out, one thing that the automakers had been emphasizing, at least for us and to our research, was, oh, these systems are separate and the control systems are completely, there's a big wall between the control systems versus the connected car systems. You folks were able to access a portion of it, right? Not all the control systems, but a portion of it.
All of them.
Oh, you got all of them? Okay.
Yep.
Yeah. Can you go into a little bit more how it wasn't
Yeah.
as disconnected as they said?
So I mean, I think that people misinterpret the term air gap. So if you actually looked on the two physical boards in the head unit, there was a gap between them, a little air gap. But at the same time, they had a connector that was a serial line that was used from reprogramming one portion to another portion, right? So in people's mind, it's two separate chips. So like, yeah, it's two separate chips. But if there's communications between these two chips of any kind, there is a possibility for vulnerability and attack. So I think people's concept of segmented portions needs the vision of someone who knows security, where they may be two separate microcontrollers, but at the same time they communicate, so essentially they're one.
The earlier panel said is this on? Okay. The earlier panel said something about consumers being able to maybe purchase a minimally functional device, purposely try not to buy something that's more complicated than they need. And you've done a lot of research with microcontrollers. Do you have any concerns that in the future we're going to have, for reasons of cost, basically a bunch of fully fledged Linux computers running around with 4 or 5 different radios in them, just because that's the cheapest way to manufacture the part?
Yeah, I mean, that's just the reality of it, right? If you buy these microcontrollers and you're a company, you want the cheapest product with the most features. So these are things that are just going to come about. I don't think, most people who make things don't want super stripped down portions of some kind of machine they're making because they want the most bang for their buck.
Thanks for the presentation. I really like your energy. I have a couple questions. Have you ever worked with drones, hacking drones? And I mean, even if not, what are your thoughts on the implications of those being hacked? Because on roads, I understand. I mean, that it's one plane. But with air traffic, I mean, we're hearing stories about drones around airports, drones around Air Force bases, and interfering with different airspace. There's many types of planes that fly at different levels, and Amazon's about to deliver everything via drone. I had no idea about the Sprint network of your thing, but if they have such a range, it's probably going to be on a network.
Yeah, I've never looked at drones, so I have no clue. I mean, there's complexities with all this stuff. So someone should do some drone research. That would be my recommendation. Someone pick up and start getting some drones and doing some research and publish it. Awesome. Good to hear.
All right. Good morning, Chris. I have to say thank you so much for bringing off this morning on such a great note. There is great energy in the room, and you brought up a point that I don't think has been touched upon yet, and I really wanted to thank you on. You notice that Harman has its fundamental flaws, and they are yet to be fixed, and we're not really too certain about that. So I wanted to ask you, in regards to these fundamental flaws, what are we supposed to be doing when there is no differentiation in memory between instruction and data? What is separating Harman's code from exfiltrating its files, from what it should be doing and determining where everything should be sent? So what should we do with this fundamental flaw?
If I had the answer to that, I wouldn't be in this room, and I'd be drinking drinks out of a beach out of a coconut somewhere. So I don't know. I mean, there's a bunch of different things you can do. You can have, I think you want to know if data's being exfiltrated. I think you want to know if you're being infiltrated, right? I mean, like I said, I worked at ISS back in the day, and there were various aspects of that product that I thought were fantastic. I think since we are moving towards these things being much like our laptops and desktops, that the security posture should reflect what we already know. There's a lot of security companies out there. Microsoft has gone through a lot of pain being the insecure poster child for years. We should learn from those lessons of these people that already had them and try to make things more secure for these things that we have.
Over here. First of all, it was a really clever hack. I admire the hack.
Thank you.
And as you know, it wasn't completely straightforward getting in because of the gap you alluded to. And because of that, I'm curious, since you have tried to penetrate these systems for some period of time, and I think it's difficult to impossible to engineer a solution with perfect security. There are people who write code for nuclear power plants or manned spacecraft or things like that who spend years and years and years trying to get the code perfect with huge teams looking at it and spending millions of dollars and things like that. So we have analysts telling us there are going to be hundreds of millions or billions of things all over the place, and they're all potentially vulnerable. And developing secure code is expensive, and we have people who try to go in and find flaws in this. What are your thoughts as somebody who's going in and finding the flaws of what the trade-off is between how much time do you spend securing it versus how do you get it out there and in the product at a reasonable cost point?
I mean, these companies aren't just security companies, right? They're product companies, and they have release cycles, and they have to get things out. I think cars are a good example, right? You want the code as secure as possible, but at the same time, you can't say there's no 2016 Chevy Cobalt. You can't say like, we'll get it out next year or the year after, right? Like, I mean, Microsoft can delay Windows 10 for as long as they want, and people are still going to buy it. But with stuff, you need to release, otherwise you become irrelevant in the marketplace. So that's a pressure that most of these places don't have. Obviously, security and getting features is always a balance beam. The one thing I do have to say is security is hard because you have thousands of kids going to university to study computer science, right? And it makes these people good programmers, and they're way better programmers than, I don't know, probably most of the people in this room, right? But at the same time, security isn't their focus. Their focus is making things that work well. So you're always going to have the security afterthought, because the concept of security and secure programming is probably lost amongst many of the people that actually write our software, whether it's antivirus, nuclear power plants, or a web app. Last one. Make it count. No pressure.
Yeah. Okay, yeah, so I wanted to sort of follow on that, because there is clearly, with billions of devices, some things will be insecure, but I'll venture to say that most of them by themselves don't represent a large vulnerability. But what you've pointed out is you can take a series of devices with relatively small vulnerabilities, and the system's effect of their being connected together results in large vulnerabilities. Do you see any approach to even systematically finding those, let alone addressing those with regulation or testing?
I'm not a regulation guy. I don't know anything about it, so I can't comment on that. But I mean, at this point, where there's just not even enough people to look at it. So there's like right now, there's no real good way to solve these problems. We need protections, and we need auditing, and you need exfiltration detection, and all these things. So it's still really in its infantile stages. I wish I had a better plan. Like I said, if I did, I'd probably be a bazillionaire and not be here today. So I don't know. Good luck.
Thanks very much.